Hello everyone. Today our lesson is about refraction of light. Refraction of light. What do you mean by the word refraction? We mean bending of light. If you look at this picture, it shows the broken pin illusion on the left occurs because the light is bent by the glass block. The bending effect is called refraction. So, definition of refraction, we will say it's the bending effect of light. Now, if you will look at this, again, if you look here, you will see the pen here, it's not straight. It's a little bit bended. Okay, why? What happened? This it's because when you will look at this pen, we said to see any object there should be a light. So now here what it's happening, a light it's striking or hitting the pen and then reflecting to your eyes. But the light it's passing into through or passing through two different mediums. Here it's what? It's air, while here it's what? It's glass. So two different mediums. Now the diagram, below this diagram, okay, it shows how a ray of light passes through a glass block. Here it's again, here this area it's air, and this area, this it's the glass, and here it's the light. See how the light, or when the light is passing from air to glass, what happened here? It bend, it refract, okay, and then when it goes from glass to air, again it will bend again, or it will refract again. So the diagram below shows how a ray of light passes through a glass block. The line at right angles to the side of the block is called normal. Okay, this is normal. Okay, the ray is refracted toward. Here you need to focus on these two words. Okay, the ray will refract toward the normal when it enters the block. Okay, here is the ray, light ray, when it's in air. When it enters the glass, see what happened? It bent. It bent to where? It bent toward the normal. Okay, this is the normal, the straight line. Okay, and then when it will leave the glass, we mean from glass to air, again it will bend, but this time it will bend where? It will bend away from the normal when it leaves it. Okay, again here, when the ray it uh, enters glass, okay, or when it will enters the glass, it will bend, but here it will bend where? This is normal, it will bend toward the normal. But when it will leaves the glass, again will refract or will bend, but this time will refract away. Also here, if we will draw a straight line, okay, here what is happening, it's refracting or bending away from the normal. So refraction would also occur if the glass were replaced with another transparent material, okay, such as water or acrylic plastic. Okay, and also the angle of the refraction would be slightly different. The material that the light it passed through it or travel through it, we call it a medium. Here, what is the medium here? It's air. What is the medium here? It's glass. Real and apparent depth. If you will look at this drawing, you will see here we have this pebble, this stone. When you will look at it, here this is water. Focus on this water and air. When you will look at it, you will see the position of it. It looks different. What's that mean? Here, this is the real depth of water. Okay, the real depth of water, and also the pebble, it's at the bottom of this water. But when you look at it, you will see it in a different position. Here it's how or where it looks, where it is. Okay, so here, to explanation for this or why it's happening, this is because of refraction. Okay, because of the refraction, so the position, it will looks different. So because of refraction, water or glass looks less deep than it's really is. Its apparent depth is less than its real depth. Then, why light is refracted? Why the light will bend when it pass through different medium? Scientists explain refraction as follows. Light is made up of tiny waves. Okay, so look at the diagram. As you can see, the black lines, it shows the light waves. When this light waves, uh, it reach another medium. Okay, what will happen? A part of it here, okay, uh, one this part or this side of the beam is slowed before than this one, so that's why it will bend. Okay, two different mediums. Light travel as waves. These waves, it when it reaches the medium, okay, this part of it will be slowed down faster than the other. That's why it bent. Refractive index. Refractive index, what do you mean by refractive index? In a vacuum, empty space, the speed of light is 300,000 kilometers per second. In air, it's effectively the same. However, in glass, light slows to 200,000 kilometers per second. So the refractive index of a medium is defined like this. Refractive index equals to speed of light in vacuum over speed of light in medium. If we want now to give a definition for refractive index, the definition will be the ratio of the velocity of light in a vacuum to its velocity in a specified medium. So here what do we have? Again, refractive index, it's what? It's the ratio of its velocity, the velocity of light. Okay, so speed of light in vacuum over speed of light in medium. Here speed of light in vacuum, here it's constant, it's always 300,000 kilometers per second. But here what will change? The speed of light in medium. Here this medium, we will change it. For example, here as you can see, we have different mediums. We have diamond, glass, acrylic plastic, water. Okay, so this is what we mean by refractive index. Then some refractive index values are given on the right. The medium with the highest refractive index has the greatest bending effect on light because it slows the light the most. Again, here focus the medium with highest refractive index, okay, will bend, the light will bend more in it. Why? Because it slows the light the most. Refraction by prism. A prism, this is a prism. It's a triangular block of glass or plastic. The sides of a prism are not parallel, so when light is refracted by prism, it comes out in a different directions. Okay, so it is deviated. And one more thing, what will happen to the light when it passes through the prism? If a white light it passes through prism, when it goes out of the prism, this light will be dispersed. What's that mean? Okay, if a narrow beam of white light is passed through a prism, it splits into range of colors. We call them spectrum. So these colors, all of them together, we call them spectrum, as shown below. This effect, the effect is called dispersion. It occurs because white is not a single color, but in fact it's a mixture of colors, and when it will pass through the prism, what will happen? Each one will refract with a different angle. Then we will have different colors. These colors together, all of them, as we said, we call them spectrum. Questions. Question number 1. Copy the diagram on the right, draw in and label the normal, the refracted ray, the angle of incidence, and the angle of refraction. Here we have this drawing. Okay, we have this line and this line, and we have two mediums, air and glass. Now the light ray, it's coming from air and will go to the glass. What do we need to draw and label? Firstly, normal. Where is the normal? If we want to draw the normal, always the normal so this, it will be the normal. This is the normal. Okay, normal, it's the point here. We will draw it from the point where the incident ray it start leaving air, entering the glass. Then refracted ray. So refracted ray, what do you mean by refracted ray? Bending of ray. Okay, now where it will be? Okay, now the light, it's traveling from air to glass. From air to glass, we said the light, it will bend where? Toward the normal or away from normal. As we said before, it will be toward the normal. So if we will draw another line, we will draw it in this way. As you can see, what is happening, it's bending toward the normal. Then the angle of incidence and the angle of refraction. The angle of incidence here, it's the angle of incidence, and the angle of refraction, so this, it will be the angle of refraction. So again, this line, it's the normal. This line, it's the refracted ray. Refracted ray, because we said it's moving from air, or the light is traveling from air to glass, so it will bend toward the normal. We will not do it in this way here down. No, we will do it toward the normal. Then the angle of incidence, this is the angle of incidence, and the opposite of it, it's the angle of refraction. Question number 1b. How would your diagram be different if the ray was passing into water rather than glass? If we will come here, if instead of glass, here it will be water, what do you think? What it will change? What will change? Because the medium will change, so the refractive index, it will change. What's that mean? The refraction, the bending, it will change. So if we will follow the table that we have here, okay, if we will change, here is the refractive index in glass, it's 1.5. Here, if we will change it with water, the refractive index of it, it's less, it's 1.33. So what will happen? The bending, it will be less in water. So the bending of this ray, it will be less in water. Question number 2a. When the white light passes through a prism, it spreads into a spectrum of color. What is the spreading effect called? Here we have this prism, okay? When a white light, it passes through it, the light, it will spread out into many colors, okay? What do we call this effect? We call it dispersion, okay? B. Which color is deviated most by a prism? Okay, this is the spectrum. Okay, which one of these colors it's deviated, or it's bending more? Okay, if you will see which one bends more, the last one, which is violet. It's the light that it bends, or it deviates more. C. Which color is deviated least? The upper one, the red. In question number 3, it says calculate the speed of light in water. To calculate the speed of light in water, by using the formula refractive index equals to speed of light in vacuum over speed of light in medium. What's the medium here? It's water. In the question, it says assume that the speed of light in vacuum is 300,000 km per second, and from the table of the refractive index, also we have the refractive index of water, it's 1.33. So how to solve it? We will write the formula refractive index equal to speed of light in vacuum over speed of light in medium, which it's water here. So we will just change the formula. Now the formula, it's speed of light in water equals to speed of light in vacuum over refractive index. It's up to you. If you want, do this step, or if you want, still you can. If you want, don't do it. Just use the original formula, replace the words with numbers, and you will find the answer. So here, speed of light in vacuum, it's what? It's 300,000 km per second over refractive index of water, it's 1.33. So the answer is, so in your book they round it, it's 226,000 km per second. So that was everything for 7.4 refraction of light. I hope everything was clear. Please don't forget to write a comment when you will finish watching this video on YouTube. If you have any questions, any concerns, please don't hesitate to contact me. Your task for this lesson is to solve the questions in the workbook. Thank you and have a good day.